All right, welcome to December 7th in the advent of coding. This is the 7th day, and we have a bit of a poker challenge here. Now, I started trying to solve this on camera, and it was going pretty well. I was even very easily able to get the test case data working, and everything was great. But there was this one weird edge case, and it wasn't even an edge case, it was more just a misunderstanding of the rules. It's slightly different in this challenge, and I'll get to that in a bit. So I ended up ultimately solving out. The video turned out to be so long that I just wanted to do a more quick one, trying to keep these, a little more bite size. So I'm just going to, sort of walk through the solution rather than making you watch, a half hour of me yelling at my computer. So essentially, the game here, it's kind of like poker. We're just trying to kind of like get the best hands and all that kind of stuff. And if you're not familiar with poker or Yahtzee even, you can read through this a little bit more. The main differences, though, are there's no suits, so we don't care about king of spades versus king of diamonds or whatever. But all the other like normal rules apply. Five of a kind, four of a kind, full house, etc., etc. So things like flushes, which is cards all of the same suit, is completely irrelevant in this game, as well as like a straight flush being better than a straight or a flush. We can ignore those things if you're familiar with poker. The other difference between this and poker, and this was the thing that kind of threw me off when I was struggling to make this work with the real data. I reread this one rule right here, and like, look at this. There's a four of a kind in threes and a four of a kind in aces, with just a trailing card. And in regular poker, this would obviously win. Four aces would win, and this would lose. However, in this game, the order of the cards you get actually matters. So when there is essentially a tie, we look at this first card here, the first time there's a change. The first card. So in this case, 3 is stronger because its first card is stronger. Similarly, this is full house, but this one's stronger. So it's this weird thing. I don't know the reasoning of that, but it threw me off, and that's why I'm doing it this way now. So let's get into it. Basically, each card, each hand comes with a bid. That's, if this was playing poker, this is like how much you bid because you felt like this was a pretty strong hand. And what we do is we rank all the hands in order, so these 5 in order, and you end up getting 5 times this plus 4 times this plus 3, 2, 1. So like if there was 10 hands, that would start at 10, 9, 8, and you're multiplying by that. And then you add all those up together, and that's like the final number, which in our test case is going to be, what do they have here? 6440. And just to make sure that I have everything hooked up correctly, let's just run December 7th a ... and we'll see we got that number 6440 back. So how are we doing this? This is by no means necessarily the best way to do it. I think it works fine, and I'm just going to actually get rid of a print statement we no longer need in here for my debugging. But I'll walk you through how we're doing it here. So, of course, we get our file. We get our lines from file. The input file is obviously this, at least when we're using the ground truth version. And we pass it into our solve function as usual. So I've created sort of this class that represents a hand. I like using objects, it's cool. And there's basically a list of strings for the cards. So that would be like, 3, 2, T, 3, K. And we have the bid number, so this number here. There's also this other thing, we'll get to that in a little bit. But we're going to construct that, and it's pretty simple to construct. We're just looping through all the rows, and we're grabbing the first after we split on this space, and that will be our cards. And we're actually splitting again to make it a list instead of just a string. And then for the bid, we're splitting again, but we're getting the last one. And we construct this, and we're adding it all here. And then what we have to do is compare the hands. And this is just a sort function that we're doing on hands, and we've made our own custom function here. So let's talk about entropy. I first wanted to attempt this using entropy, and it ended up working fine. And entropy, the idea is the more random something is, the more entropy it has. Meaning, if you have all of the same card, like 5 kings, for instance, you're going to have a very low entropy. And if you have 5 all different cards, very high entropy, and everything in between. So I kind of fudged together this entropy function, just a getter on it. And basically what it does is it keeps track of the char count of our it's like a map here. It's starting empty. And basically we loop through each card. So that's like, you know, the 3, the 2, the T, whatever. And we set a key in this. And if it already exists, we basically set it, or if it doesn't exist already, we set it to 0 plus 1. If it does exist already, meaning this isn't null, it's going to take whatever we're at and then adding 1. So it's just a way to, in sort of like one line, be incrementing a number here or adding a new key. So you can imagine this would ultimately, you know, look like something like, you know, K, there might be 2 Ks in there. Queens, there might be 1 queen. And as it's going through, if it finds K, a key for K already, we then just add it to that number instead of adding it to 0. So that's just creating us this nice little map of that. And this entropy function basically is just kind of like figuring out the count, dividing it by the total chars, doing this logarithmic scale, and reduces it all. So you end up getting a number back. It's a double, so it might be like negative, you know, 0 point. In fact, I have them printed out right here, all the way up to here. And in this game, lower entropy is actually better. So that's how we do the entropy. And we check, first of all, let's just pretend the entropy is different. If the entropy is different, meaning we're comparing 2 cards that have different entropies, we already know just by the rules of this game that the one with the lower entropy is going to beat out that one. And that's simply because having 2 of a kind is better than not, you know, than having just a bunch of 1 of a kind. So lower entropy is going to win. However, there's going to be many cases where the entropy is the same, and that could just mean that you have, you know, 2 aces, 2 queens, and a king, and then on the other hand, 2 4s, 2 3s, and an ace, whatever. They both would have the same entropy based on our rules. So in here, what we actually do is we go through the cards, and in the case of those cards, so it's going through, it's looping through all the cards, and it's checking card A at that index and card B at that index. And if they are the same, we just continue through the loop again. But when it finds a different one, it's going to do this card has higher value. And all this does is we have this lovely map here of all the values, ace, king, queen, jack, all the way down. And essentially we just go, if the index of it is higher, so like if the index is higher, it finds a 2 or a 3, then compared to a king, we're going to, you know, sort it by that. And that's basically that. And then we use the multiplier function. And this is really simple. Once we have them in order, we start with a score of 0. The multiplier is going to start at the hands.length. So it'll be 5 in this case. And we just basically take the bid times the multiplier and keep summing it to the score. And then we bring the multiplier down by 1. So ultimately this very last one will be multiplying by 1. And then we get our score back. So we do that and everything's good. And we got back that lovely number. So yeah, that was kind of that one. It was pretty straightforward. Again, the only thing I had what was messing me up with my real data, although the problem was the test case didn't have this issue. I ran into a problem when because I had this extra code that was already that was actually sorting things to handle like essentially the opposite of this one example here that I thought was pretty dumb. In my case, this hand was considered better originally than that one, and that was throwing off my numbers. But funny enough, in this small sample data, you know, it didn't matter, and I was like, why is it working there? Anyways, that's part 1. Part 2 adds this interesting thing. So I'll open up that one. It's more or less the same. I'm not going to walk through everything the same way. We'll skip over the irrelevant repeated parts. But in this one, the main difference is now Jays are now jokers, not jacks. So, however, in the case where there's a tie, the joker count is considered. And joker is actually the lowest value card. So that's just like one little nuance there. Yeah, in order to do this, we'll just kind of step through it, but I won't explain all the things. So I still do the cards the same way, except I have this function now to replace the jokers. And there's probably a better way to do this, but basically I want to find out how many jokers are in here, how many J's. In the case that there's 0, I'm just going to return the cards as is. And in the case that there's 5, you know, we would want to create the best hand, which is 5 aces in poker. So I just get those out of the way, although there's probably a way, like not having these might not matter. I'd have to check, but this was just something I thought of, like, okay, in these 2 cases, we know what the response will be. And then what I want to do is loop through all the cards that aren't a joker. So I'm doing a where on where the C isn't joker. And I want to do that frequency map idea. This is very similar to part of the entropy function. So we're just basically doing, it's literally the same code. We're just not doing the second step of the entropy here. And what I want to do is find the best card. And to do that, I just do a map function on the keys to essentially find what the best card is. This will return a string. So this means, because what we really want in this case is, like for this last one here, we don't want an ace to come back. We would actually want a queen because there's more queens, and 4 of a kind is going to be better than replacing this ace with, or this jack with an ace and getting just a full house. So we're really just looking for what card comes out, you know, the most in here. And then, and I made a little bit of a boo-boo here. I was like, oh, I'll just do a replace all. And I realized, no, there's only a certain amount of jokers. So I essentially start the list with 0, and we're going to keep incrementing until the joker count's used up. So there might be just 1 joker, there could be 5, that kind of thing. And what we do is we take the cards, and I just turn it back to a string really quickly to operate it on. And I just do a replace first. So the first J that it finds, I replace it with that best card, and then convert it back to a list. So this is a list again. And now when this runs through the second time, the replace first will be the next J, because that J is going to be gone. So that's how we get that. And I'm actually tracking this. I made a small update to the model for this one. I wanted to track the replaced cards while still keeping a reference to the cards. So when we actually construct this, we're passing in both our original cards and the replaced cards. Okay, then we run this same thing. We compare hands. Now this has a slight difference to it. If I actually, there might not even be, I might have just kept the same function. Let's look at both real quick before I say something incorrect. Beta entropy. Nope, actually there wasn't a change made there. So everything else is still the same. So we basically, yeah, just got to sort the cards. I just had a print statement here for debugging purposes, but we do the same thing and we get our thing back. And if I turn this to B, we should see we get the 5905, which is right here, 5905. So that's how I handled that one. This one I definitely I struggled with, and I think I just got mostly frustrated because of that one little rule that I didn't really notice. Because I play poker a lot, you know, I know how poker works, and I just didn't notice that the way it was worded. So, yeah, that's it for this day, and I'll see you in the next one.